Hello, everyone. We're going to get started.
That's not.
That's not on. Hang on. There we go. Hello to everyone on the island and to all our IRAS webinar folks. Let me give you an idea of what we're doing here. It's kind of like the multiverse. So everyone who's here, you are here for Wake Smith's presentation tonight. We've got an audience on our IRAS webinar. And we also have an audience on Star Island. And for those of you on the webinar who don't know, this is our annual Star Island conference. And this year we're doing the Wizards of Climate Change. How can technology serve hope and justice? So the other thing we need to do is talk a little bit before Wake starts about the Q&A. So if you're on the webinar, what you'll want to do, and you can do this anytime during the talk, go ahead and put your questions in the chat.
No, Q&A.
The Q&A, okay, there's a Q&A. Put your questions in the Q&A, not the chat, Q&A. And at the end of Wake's presentation, we will be alternating between questions on the online Q&A. And for those of you here, a little bit different than what we've been doing, you need to come queue up, maybe queue up over there, ask your question, and then go back to your seat so the next person can come up, okay? So a little bit different than what we've been doing. Before we turn to Wake's presentation, let me just tell everyone on the webinar and all of you here, because you'll be home by then. The next IRAS webinar, Monthly Science, Religion, and Society, topic will be the wisdom and resourcefulness of the whole, and that will be by Tom Atley. Tell you a little bit about him. He's a former peace activist, and he's a founder of the nonprofit Co-Intelligence Institute. He explores what intelligence looks like when it takes wholeness, interconnectedness, and co-creativeness seriously. And that will be at 5 o'clock Eastern time on July 11th. Okay, so that's the next webinar series. Tonight, I'm very happy that Wake Smith accepted our invitation to speak with all of us. His title is Overshoot, the World Beyond 1.5 degrees C. Let me tell you a little bit about Wake. He's a lecturer at Yale University, where he taught an undergraduate course on climate intervention. And the syllabus of that course went on to become the outline for his book, Pandora's Toolbox, The Hopes and Hazards of Climate Intervention. And this has really become my go-to book. I can't recommend it enough as a solid entryway into thinking about these things. Wake Smith is a senior fellow at the Harvard Kennedy School, and he writes on aeronautic costs, the governance of solar engineering. And prior to that academic career, he worked in several executive roles in the commercial aviation industry. And well, some of us were speaking ahead of time. Wake has actually been on Star Island in the 70s. He was here, I guess, for a UU youth event. You got to come back, Wake. It only gets better. What else can I tell you? I know Wake thinks I probably was stalking him at the last AGU meeting, but really I was just trying to learn as much as I could about climate intervention. And everywhere I went, there he was, often giving a presentation. So it really is a delight. And Wake, thanks so much for agreeing to speak with us tonight. We're going to turn you on now.
I am turned on.
There you go.
Thank you kindly for that introduction. I was indeed raised in the Unitarian tradition, and so I have been to Star Island as a young man, trying to contemplate life's big questions. I have gotten older, but I'm not clear I've gotten wiser, and that I still contemplate life's big questions. And one of those that I ponder these days is whether I and maybe we are in an sort of ethically compromised status. In that when I was a young man, when I was at Star Island as a teenager, I had never heard of climate change. It wasn't on my radar screen at all. But we're no longer in such a world. Climate change is established science. There's lots of open questions about climate sensitivity and how the planet will react, but there's no longer any scientific controversy over whether climate change is happening, whether it's caused by human activity, whether it is problematical. All of that is settled science. I often speak at scientific conferences. I spoke to the National Academies last week. I'm headed to the UK tomorrow to speak at a scientific conference, which is part of the reason I'm not there in lovely Star Island today. But in those settings, I'm trying to describe the world as it is, or at least as best I can perceive it. But describing things in a positive, i.e. predictive frame. But in a conference such as this one that mixes spirituality into the mix, it's also sensible to talk about and think about climate from a normative perspective, not what will happen, but what should happen. And if we think about climate and what should happen, what intergenerational justice demands of us, it's pretty clear what we should do, which is we should not live as we do live. We continue to consume more of the planet's resources, and in particular, deploy into the stratosphere more greenhouse gases than the pre-existing climate can stand. We are doing that every year, and we are continuing to do that, and we know that that will have dire consequences on the climate that we will bequeath to our grandchildren and great-grandchildren. And so it's clear that we should stop doing that. But I have become quite clear that we will not stop doing that we will continue to live approximately as we do live, and continue therefore to put more greenhouse gases into the atmosphere than the current climate, than is consistent with the current climate. We will change the climate by doing that. And despite hopes that we might turn that corner soon, I don't, back to my positive frame as opposed to normative frame, I don't see that happening. Emissions continue on the trajectory that they roughly have been historically, and we haven't yet turned that corner. But the problem ethically is that now we know what we are doing, but it is very difficult to stop doing it. And I wonder about that. I wonder what response is called for personally. I wonder what response is called for as a species. But I think I will have difficulty explaining to St. Peter at the pearly gates how it is that I continued to live the life that I live, knowing what we're doing to the planet. Now I'm a Unitarian, so in fact, we don't have final exams in the Unitarian religion. I don't have to worry about St. Peter. But if I did, I know that I would be in a very long line of people with the same dilemma. So anyway, I do, maybe this is on my mind because I've submitted today an academic paper on the ethics of climate change. But I wonder. Moving to the bulk of my presentation, are you all seeing my screen there? I think not, actually.
For my
Now we got it.
Yep. So as I as Carolyn mentioned, my talk today is on Overshoot, which is a continuation of the explorations I did in this book, Pandora's Toolbox, that was published a year ago. And let me jump into it. So the Paris Agreement, in my view, has fostered naive hopes about 1.5 and 2C temperature targets. Written right into Article 2 of the Paris Agreement is both a 2C goal and a 1.5C goal. That's a typical political compromise that arises as different parties negotiate a thing. It would have been cleaner had they chosen a single goal, but they couldn't agree on one, and so they chose two. We are meant to hold the increase in global average surface temperatures well below 2 degrees and pursue efforts to limit it to 1.5 degrees. The very year that this agreement was agreed, which was 2015, there was a lot of skepticism in the scientific community about whether these goals were realistic. And so the IPCC, the Intergovernmental Panel on Climate Change, followed the Paris Agreement of 2015 with a special report in 2018 that tried to illustrate the sorts of emissions trajectories that would be required in order to meet the 1.5C goal. And so there's a series of 90 models modeled herein, but there are 4 of them that are the primary ones called out. 3 of those 4 share the same characteristic, which is that in 2020, they all plunge off of a cliff, whereby we're meant to substantially cut our emissions by 7% per year through the entire decade of the 30s. The slope changes as we get into the 40s, as we begin to eliminate the harder to eliminate emission sectors. But the concept is that by mid-century, roughly, we are meant on all of these pathways to drop below net zero. That is to say, to not only stop emitting on a net basis, but actually later in the century, capture more carbon from the atmosphere than we emit to it. So we begin negative emissions. And if we do all of that, slash our emissions in this decade, eliminate them over the following couple of decades, and then remove carbon from the atmosphere in the latter half of this century, all of that gets us to this 1.5C goal. And yet, we did cut our emissions in 2020 by about 7%, but we did that by arranging a pandemic which wrecked the global economy. That certainly wasn't what was intended in those emissions pathways. But you'll see here, this is emissions by quarter, seasonally adjusted. We did have a big dip in 2020, but it snapped back in 2021. And we are now each quarter setting new records for emissions. So not only have we not begun this luge-like slope down the emissions curve that would be required to reach 1.5, we're still setting records for emissions. The line is only only a slight upward slope, but the slope is upward. Now this is the part where you jump out and say, wait, you dummy, don't you know about the spectacular growth of wind and solar? And yes, I do. Wind and solar have seen spectacular growth in the last decade, and that continues. Here is a graph of all renewable emissions energy generation globally, and you see a dramatic peak. The problem, however, is that the demand for fossil fuels is also growing. And so to capture share from fossil fuels, wind and solar have to grow faster than fossil fuels are growing. And the good news is they're doing that. They also have to backfill the lack of growth in nuclear power. We're not reducing the world's nuclear fleet, but we are not growing it. And so in a growing pie, nuclear is losing share. And only after wind and solar keep up with the growth in energy demand generally and backfill for the lack of growth in nuclear, only then do wind and solar begin to capture share from fossil fuels. But the bad news is fossil fuels still comprise more than 80% of the world's primary energy supply. That statement has been true for all of my lives and all of your lives. Renewables are a factor, but they're still a small factor. The spectacular growth of wind and solar in the last decade means that they went from roughly 3% of global primary energy supply 10 years ago to roughly 4% today. So we still aren't in a circumstance where wind and solar are coming anywhere near putting fossil fuels out of business. We can hope that that will happen over time, but it's not happening very materially yet. Moreover, there are other things that are pulling against us. One of them is population growth, to the extent that we've got 7.6, 7.7 billion people on the planet now, and we're projected to top out at 9.5 perhaps, or 10 late in this century. Another quarter or a third of humanity, a quarter we'll call it, all things being equal, that will likely entail another quarter, another 25% addition to global emissions, all things being equal. And moreover, we hope that the global economy continues to grow, particularly in the global south, where they are seeking to catch up to the lifestyle that we live in the global north. But again, more economic growth, all things being equal, means more emissions. Now, the good thing is not all things are equal. Population is working against us, economic growth is working against us, but the decarbonization of the energy supply, that's working for us, not as quickly as we need, but it's a positive trend. And so too is the greater energy efficiency of the economy. The more that we move to a service economy, the less energy intensive our economy is. So it's not that all of the news is bad, but rather decarbonization isn't a luge down a ski slope. It's a tug of war between opposing forces. And unfortunately, the forces of more emissions are continuing to win that tug of war. The Ukraine war also demonstrates that carbon intensity of our energy supply is by no means the only consideration in respect of energy. Energy cost and very importantly, energy security remain utterly vital, as Europe has had to learn the hard way in the last year. And yet there remains a hope that we can reach 1.5, keep 1.5 alive, was the cry that went out in the streets of the Glasgow COP conference nearly 2 years ago, and a winning photo of Greta Thunberg trying to hold us all to account. But getting to net zero, despite Greta's earnest wishes, and all of ours, I'm sure, getting to net zero will be difficult and slow. This is another indication of the downward ski slope that we ought to be on. And yet, if one adds up the pledges and targets that the nations of the world currently have on the table, it is roughly a leveling, perhaps even a continued increase of emissions. And not all of those pledges and targets will necessarily be kept. So we continue to be in a circumstance where we know what we need to do, and it's very hard to do it. The IPCC has historically been an emissions trajectory cheerleader and has sought to coax the world into better behavior. But in the latest IPCC reporting cycle, the IPCC 6 report, which came out in chapters over the last couple of years, the IPCC began to portray a different reality. This is another set of emissions trajectories going forward from 2015. And you'll notice the two on the bottom look somewhat like our ski slope. We go down and go to net negative emissions late in this century. The two on the top blow the lid off of our emissions, but focusing on the line in the middle, the sort of orange-ish line labeled SSP2 4.5, that's what the the IPCC labeled in this AR6 report as the quote, middle of the road trajectory. And you'll see that the middle of the road trajectory that the IPCC has put out is not that ski slope in blue at the bottom. Rather, it's continued rising, a leveling of emissions through the middle of the century, and then a slow decrease of emissions through the latter part of the century. But you'll note that even in 2100, we're not all the way to net zero in that middle of the road projection. Now, projections are not predictions. The IPCC is not exactly predicting this, but this is now what it is representing as the middle of the road estimate. And where that middle of the road estimate would take us temperature-wise is plus 2.7 as an average temperature in the last 2 decades of this century. So 2081 to 2100, an average of 2.7 degrees above the pre-industrial baseline. So not 1.5, not even 2, but 2.7, and we're not done yet because we're still not at net zero. So that 2.7 probably leads to a roughly 3C temperature anomaly early in the next century when we might get to net zero if you believe this projection. And again, they've got higher and lower projections. But I do think this is a reasonable projection and more reasonable than the others, in which case we're sailing off the edge of the climate map into climate regimes that our species, Homo sapiens, has never seen. The planet has seen them, but we haven't. There are a few details that illustrate why it's so difficult to get control of our emissions trajectory. The one I was focused on earlier was the difficulty of reordering an energy system that is still overwhelmingly based on fossil fuels. But another important climate concept to understand is tank and flow. This is a tank and flow problem in which, and the analogy that is often used to illustrate tank and flow problems generally, and climate in particular, is a bathtub. So you've got a faucet of emissions coming into the bathtub, or a faucet of water in the bathtub analogy. You've got a bathtub that is the reservoir in which those that flow is residing. And then you've got a drain by which material is removed from this system. In the climate context, the faucet is our ongoing flow of emissions. The bathtub is the concentration of greenhouse gases in the atmosphere. And the drain is the natural process by which Mother Nature removes greenhouse gases from the atmosphere. The problem is that greenhouse gases are not like particulate air pollution, whereby if we stopped polluting, suddenly via magic wand, a couple of weeks later, the air would be cleaner. Beijing did that before the Summer Olympics a few decades ago, and they turned off all the factories and told the cars they couldn't drive. And sure enough, by the time of the opening ceremony, the skies were clear over Beijing. Climate doesn't work that way. There are 3 primary greenhouse gases that we care about. There's methane, which breaks down, if we put it into the atmosphere, it breaks down after about a decade. So that goes away pretty quickly. There's N2O, which breaks down over roughly a century. But the vast majority of our greenhouse gases, more than 80% of them on a greenhouse gas equivalency basis, is CO2. And CO2 takes centuries to millennia to break down and be removed from the atmosphere via the natural processes. So our problem then is that we've got a faucet of greenhouse gas emissions flowing in, and the unit is roughly 50 gigatons, but forget about gigatons, it's 50 in. The drain is draining at less than 1 per year. So we've got a huge imbalance of 50 coming in, and let's call it 1 coming out each year. So the bathtub gets full each year by 49 more gigatons of greenhouse gases. And it's that concentration, it's the level of water in the bathtub that informs the climate, not the emissions flow. So if we cut emissions in half, which would be an astonishing achievement, the bathtub is still rising because the drain is essentially clogged. That's why we've got to get all the way to net zero, and that's a daunting challenge. After all, this is the actual measurement of CO2, rather, not all greenhouse gases, but CO2, the main one, at the Mauna Loa Observatory in Hawaii since the late 50s. And you can see that the concentration of CO2 in the atmosphere, the level of water in the bathtub, continues to go up and to the right. Another very difficult aspect of this problem is the global mixing of greenhouse gases. Again, particulate air pollution from a smokestack affects the 20 or 50 miles downwind. If it's a huge source like the Canadian wildfires that we've been seeing, it may flow hundreds of miles, but there's a limited radius downstream where that pollution has effect. CO2 and methane are not like that. They are very efficiently globally mixed. So to the extent that we clean up our emissions in the US, but other countries fail to do so, the bathtub keeps filling, and it keeps filling globally, just as much in the US as in anywhere else. Moreover, after net zero, because of the long lifetime of CO2 in the atmosphere, global warming doesn't stop. It just stops getting worse. But I'm afraid there's a perception that once we get to net zero, we're good, we've solved the problem. No, we've only stopped it from getting worse. But that CO2 that we put there hangs around for centuries to millennia, essentially forever, if one is thinking about it on a human timescale. And if temperatures merely stabilize after we get to net zero, but they don't go down, and high temperatures inform high climate damages, then climate damages don't abate after we reach net zero. They too simply level off. Temperatures used to be pretty stable. The amount of flux that we saw in temperatures since the beginning of the Common Era was quite small. In fact, we were in a slight cooling trend prior to the pre-industrial era that it was referred to as the Little Ice Age. You can see, though, that since the industrial era, really since about 1900, temperatures have shot up from the baseline that is used in the late 18th century all the way up to above 1.1 C today. So we don't have, to meet the 1.5 C target, we only have about 4.4 C left to go. The point of this slide maybe is repetitive of the last one. It demonstrates that we've increased by 1.1 degrees Celsius since this pre-industrial baseline. One can imagine that 1.1 degrees, 1.5 degrees, 2 degrees Celsius, these are very nearly nothing. The average the daily temperature between dawn and 2 p.m. moves much more than that every day. So how much of a difference could 2 or 2.5 degrees C make? Well, in the last ice age, it was only 5 C cooler than it is today, 5 C Celsius. And 5 C Celsius resulted in a kilometer of ice on top of Star Island and all over New England and North America and many other places as well. Now, this was 5 C in the opposite direction, 5 C cooler. But if 5 C cooler results in a global ice age, 2 or 3 C warmer can have huge impact on ecosystems and agriculture and people all over the world. And yet none of what I'm saying is intended to convince you that we can't get to net zero or that we shouldn't get to net zero. We absolutely need to find a way to get to net zero as quickly as we can. But I'm deeply worried that that isn't likely mid-century as these Paris compliant goals would urge us. You'll notice I've got a net zero plot here, but I've taken the years off the bottom. It's hard to predict, but mid-century does not look like a good prediction. The damages that would arise from temperatures above 1.5 C and above 2 C in this century are well known to people. It will be hotter. The intensity of storms, though not necessarily their frequency, will increase dramatically. Forest fires will become a greater problem, leading to permanent deforestation of many areas that are now forested because it will be too warm for that ecosystem. But the changes that I worry about most in my lifetime are hydrological changes. So many of the world's great rivers are fed by permanent glaciers. And if those glaciers recede and ultimately disappear, and glaciers in the tropical world are doing exactly that, that will result in not only drought, but desertification of land that is currently arable. And if people can no longer feed themselves where they live, where do you think they're going to want to come? They're going to want to come to the areas of the world where agriculture is still viable, which is to say, among others, North America and Europe. And I don't see how we're going to stop that. We're going to turn away starving people. That I don't see that world. So the climate problem is going to require lots of tools, a broader array of tools than is generally discussed in climate discussions. We certainly need mitigation. That's the term generally used for emissions reductions or decarbonization. It's absolutely critical. It's the number one thing. I don't mean in any way to distract from that message. I'm by no means a climate denier. We absolutely need to mitigate, but I'm afraid it will be insufficient. Mitigation alone won't get us to a climate that our great-grandchildren will be happy with. We will also clearly need massive adaptation locally, regionally, nationally. That will require huge funds flows within countries and between countries. There was just a conference in Paris this past week to try to convince wealthy nations to help fund more of the adaptation required of poorer nations. That conference didn't go well. But in addition to mitigation and adaptation, which are the customary tools that the IPCC has long discussed, I think we will also need carbon capture as well as solar geoengineering. And a few words on those. Carbon capture people immediately think of trees, which are superficially attractive, but they're in fact fragile and saturable sinks. After all, the natural fate of forests is flame. They give their carbon back to the atmosphere, either tree by tree as the trees die, or all in one big conflagration, as is happening in Canada. And the amount of land that would be required to achieve the 1.5 C temperature goal through afforestation or reforestation has been estimated at 1 to 3 times the size of India. And all of it's got to be land on which forests can grow. There just isn't that amount of unused land in the world. People also talk about soils and blue carbon, which is restoring coastal mangroves and perhaps ocean liming. But I'm afraid most of these biological approaches will be helpful on the margin, but they're 5% of the problem or 10% of the problem. What we desperately need to start doing as a society is capturing CO2 and other greenhouse gases where they're most concentrated, and where they're most concentrated is in a smokestack that they're about to exit. So the most essential carbon capture priority for the world is not planting trees, but putting scrubbers on top of smokestacks. We have about 30 large plants that are doing this today, out of about 10,000 that are of this scale. And so we are capturing like 1/10 of 1% of our current emissions. We know how to do this. The barrier is financial. There's simply no financial incentive to do it. And so all of the 30 projects that are doing it are demonstration style projects. Until there's a cost to emitting carbon, people will continue to emit it. But hopefully over time, we do find ways to limit carbon emissions, both by decarbonizing the energy cycle and by capturing such carbon as we continue to emit. And so eventually the opportunity to capture from smokestacks before it is emitted will be exhausted. In which case we then need to start capturing from direct air. This is the negative emissions that was contemplated in that 1.5 C IPCC report that I showed on the third slide. How would we do negative emissions? Again, it ain't trees, it's big metal machines that look a lot like the machines that got us into this problem. But it's those sorts of machines that have the capacity to substantially scrub our atmosphere. And then that carbon's got to be put underground. If we keep it on the Earth's surface as trees or soils or mangroves, it will stay in the carbon cycle and continue to cycle back into the atmosphere. Basically, what we need to do is capture from the air and pump back underground the hydrocarbons that we're still capturing from underground and pumping into the air. We need reverse oil drilling. But that is penicillin to the climate problem. If we finally stop emitting and we want to start making it cooler, this is how we could do that. And yet it will have taken us several hundred years to put all that carbon up there. So if we suck it out of the atmosphere at the same pace that we're now putting it into the atmosphere, that might take centuries. And someone who turns 20 in the net zero year, if you're telling them the climate is pretty terrible now, but don't worry, if you wait a few centuries, direct air capture and geologic sequestration, they can solve the problem. That 20-year-old person isn't going to stand for that. That doesn't help them in their lifetime. What could help them in their lifetime in a too hot world is finding ways to reflect out a little bit of the incoming sunlight that contributes the energy to our climate system. And there are a variety of demonstration ideas that people have theorized about how we might do that. space shields or painting roofs white or engineering crops to be a little bit lighter in color. I think these two, they're a bit like the biological removals I discussed earlier. They're mostly fanciful ideas. But the one idea that we are pretty convinced would work is referred to as solar geoengineering or stratospheric aerosol injection. This would mimic what volcanoes do naturally, which is to put a little bit of sulfur dioxide into the atmosphere and deflect out maybe 1 or 2% of the incoming sunlight. Large volcanic eruptions that happen a few times a century demonstrate that this substantially cools the Earth for as long as those particles are in the stratosphere. And it's clear that we could generate the same sort of effect by spraying such particles from aircraft. We can't, however, spray them from normal aircraft because we've got to get those particles high in the atmosphere in order to keep them aloft. If we put them in the troposphere, the lowest level of our atmosphere, they'll rain down in a week with the next rainstorm. But if we get them up into the stratosphere, which is why powerful volcanoes are the ones that do this, but normal volcanoes don't. If a volcano is very powerful, it blows this SO2 up through the troposphere into the stratosphere. And there it lasts for a year to 18 months because it gets caught in what's referred to as the Brewer-Dobson circulation. So if we put SO2 into the stratosphere near the equator above the troposphere, it would then get caught in this Brewer-Dobson circulation. It would go from the equatorial regions to the polar regions in both poles. It would be distributed around the Earth east-west via the spinning of the Earth. And you could therefore create an artificial veil over the entire Earth that would deflect out a little bit of the incoming sunlight. Normal aircraft can't do this. They can't get high enough. So your passenger jets, your military tankers can't get there. A fighter jet in a ballistic climb can get there, but it carries essentially nothing. The Global Hawk spy plane could get there, but it carries essentially nothing. None of these aircraft will work for this purpose. And neither would balloons or rockets or guns shooting shells from the surface or hoses that are tethered and suspended by a balloon. None of these platforms work either. But we're not out of luck in respect of platforms. We could, and I have with former Boeing engineers, designed a lofting platform, an aircraft that could haul substantial payloads of reflective material to the high altitude that would be needed. But this plane does not exist yet and would take roughly 20 years to develop and then manufacture. So we're by no means right around the corner from being able to do any of this. And if we did it at all, we would do it all over the world, in both the northern and the southern hemisphere, in the tropics and in the subtropics. You would distribute it around the world so that it was not beholden to any single country or regime. This would be a global solution if it's a solution at all. And what it would be most effective at doing is dealing with deadly heat waves that are predicted to be one of the early, very large problems that would arise in a +2C world. But if we do begin to get deadly heat waves that threaten the lives of many, many people in the equatorial regions of the world, it's too late to solve that problem via mitigation. It's too slow to solve that problem via adaptation. It's too slow to solve that problem via carbon capture. But solar geoengineering potentially could substantially ameliorate that problem. Now, what could possibly go wrong with a huge atmospheric experiment on the only planet that we have? Well, all sorts of things. By no means am I presenting this as a panacea. there are bad physical consequences that we already know about: stratospheric heating, acid rain, a slowing of the recovery of the ozone layer. All of those are things that are certainly possible here. The greater fear, of course, is unknown unknowns, things that we have no experience with because we're not doing this. Volcanoes are one-time blasts, but they're not a continuous veil, and bad stuff could happen that we don't predict. There's certainly the prospect of political conflict that could come out of such a regime due to divergent climate preferences or questionable legitimacy of such a venture. Equity and justice issues present themselves here as they do throughout the climate issues. So those aren't unique to this problem, but they arise here as well. Because of the concern about all of that, most of the energy related to solar geoengineering in particular is about the governance of it. And the tug of war between those who seek more research of this, illustrated on the left, an experiment proposed by colleagues of mine at Harvard to better understand how these processes might work in the stratosphere, versus a much larger group of people who think these are dangerous technologies that ought to be kept in a bottle and are against not only deployment, and there's no one that's arguing for deployment at this time, but there are people who are against research as well. So this is a very hot topic and controversial topic in the climate community. This is also often presented as a break glass in case of emergency sort of tool that we can go along as business as usual. And if we suddenly pass a tipping point that we're very worried about, then we can whip this solution out. I don't present it in that way. Firstly, tipping points will probably only be seen in retrospect. We'll only know there was a waterfall there after we go over the waterfall. And as I earlier mentioned, there's roughly a 20-year ramp up to implementing such a system. So it is not an instantaneous solution unless we are preparing for it in beforehand. Once we're deploying, the climate impact would be very rapid within a year, but it's not a rapid program to start. And that's from a purely technical standpoint. Again, putting together a governance regime globally that would have legitimacy, perceived the legitimacy to govern such a system may take even longer. And yet I am worried. I'm worried that we have much more climate change in our future than the world is generally aware of. And so I think we will need carbon capture, firstly, to hasten the pace to net zero by offsetting our ongoing positive emissions, offsetting emissions that we have real trouble eliminating, but also for repairing the climate after net zero. And I think that's where the vast majority of carbon capture may come, not before net zero, but after net zero. Solar geoengineering is not an alternative path to net zero. It's not plan B for problem A. We still need decarbonization. We still need to get to net zero. If solar geoengineering is anything at all, it's plan A for a different problem, which is how the next century might survive the climate damages that I'm afraid we are exporting to it. So that's my cheerful speech.
Thank you, Wick.
Hi, thank you. My name is Mark Cooperich. I'm from Vermont. I loved your slide where you showed the input of the bathtub at 50 units, and then the output that we were capable of doing naturally was 1 unit. So there's a delta of 49 units. My question is, what percentage of the bathtub volume is that? Is that 1% of the bathtub, or is that 0.00% of the capacity?
Of course, there's no fixed capacity. The atmosphere will take all the carbon we stuffed in it, but we've got another roughly 400 units that we can emit until we hit 1.5. We've got roughly another 1,000 units that we can emit until we get to 2 degrees Celsius. So I'm afraid that at that pace, we're going to hit 1.5 in by the end of this decade, and perhaps 2C by mid-century. So at roughly 50 a year, we're heating the planet pretty good.
I'm Paul Carr. We know that right now the oceans absorb a good fraction of our carbon dioxide. And we also know that there are microplankton near the surface that have carbonate cells. And if we can accelerate the growth of those microplankton, we'll sequester these carbon dioxide in their carbonate cells. And then when they die, they'll sink to the bottom of the ocean, and we've sequestered carbon. Now, how about that as an approach?
It isn't yet clear that that's a winner. What we have, I referred very briefly to ocean liming in an early slide. But ocean iron fertilization is yet another technique that would do a similar thing. It's clear that there are dead, or at least dead-ish zones in the ocean. And if we put good stuff, biologically good stuff in those zones, it will stimulate biological growth, and those growing critters will absorb carbon, just as you say. The problem is that it isn't clear what happens to that carbon once those critters die. It has been theorized, as you just mentioned, that they build a shell, the shell drops to the bottom of the ocean, that carbon turns into limestone, and we sequester that carbon forever. No one's demonstrated that it works that way, and there is, and it's very difficult to demonstrate that it works that way. So it's clear that you can stimulate biological activity in the ocean. It's not clear that that sequesters carbon in a permanent way. And moreover, we've got other ocean problems. As we warm the oceans, which we're doing, the oceans can hold less CO2. So they will hold a lesser fraction of our emissions in the future than they do today. That's a problem. Yet another problem is, in the same way that the oceans giveth, the oceans taketh away. So right now they're absorbing about a quarter of our CO2. We put 50 units in the atmosphere. Well, we put 40 of CO2, roughly 20 of it stays in the atmosphere, 10 goes into the soils, 10 goes into the oceans. But if later we get to net zero and we then start pulling carbon out of the atmosphere, the oceans will give carbon back from the oceans to the atmosphere. So we've got to pull yet more carbon out of the atmosphere to adjust for the fact that the oceans equilibrate in both directions. So it's the ocean liming or other ocean stimulation of other ocean biological activity is one of the areas where I'm most eager to have more research performed. And this isn't my area, so I'm a consumer of that research, but I'm eager to have better research that determines whether stimulating life in the ocean does result in permanent carbon sequestration, or it's simply like planting a tree. The tree grows, it absorbs some carbon, then it dies, and it gives the carbon back.
Yes, hi, I'm Eric Orz. I'm from the University of Pennsylvania, Columbia Law School. You started off with a comment which has related to a number of other presentations that we've heard so far at the conference about ethics. And I agree with you, and you support the argument from a scientific and technological standpoint. I agreed with pretty much everything that you said about that, but I wonder if you could comment specifically on the problem of your view, at least, of how the ethical mandate can be better communicated, because right now, it seems to me at least, and I think a number of other people, that the reason you're not seeing progress on some of the technologies that we already have that would start to make a difference is an ethical problem, a communication problem, a political problem, because some entrenched interests, particularly the fossil fuel industry and others, very much like the idea of investing in carbon capture technology, but don't like the idea very much of being replaced by other kinds of energy systems. So I wondered if you could comment on that dimension of the problem.
So I really do puzzle over this. Again, I spent my first career in aviation. So did I toil in an evil industry and not know it? I hope not, but I'm not sure. But I guess one place that I do diverge from most of my academic colleagues is that they perceive the bad guy to be Exxon. And if we can just beat up Exxon with taxes and regulation and other stuff, that we can turn this corner. I'm afraid this is a cake we're all eating together. When I went to the gas station, a few days ago, what I put in my car was gasoline. And the plane that I'm going to fly on tomorrow runs on Jet A. And it's not, I don't think that it's bad fossil fuel guys doing it to us. I think we're doing this to ourselves. We're all, Exxon exists because we buy their products. And that makes it then a more challenging ethical thing. If it's we who are the problem, holy cow, what does that mean? And I really don't know. Should I, as a former aviation guy, should I swear off flying?
Well, I think a lot of people just said yes, but when I ran for office, actually, I was forced to make a pledge not to fly. But I think, in all seriousness, in answering your question, I've mentioned this book here before, but my colleague at Penn, Michael Mann, has a book called The New Climate War, and I think it is a mistake to say, well, it's all of our problems because we drive and because we participate in the economy that we currently have, and I think Michael Mann demonstrates this, is a tactic by those who don't want change to put the blame morally on individuals and consumers and citizens when you really don't have a choice unless the system changes. So there is some evidence that, in fact, I don't want to just blame Exxon, but that there is some evidence now that the oil companies have in fact attempted to use exactly that tactic by saying, hey, you drive gas too, so it's your problem as well. That's really, I think he makes a good case. That's not really a fair argument. And it does make sense to point out who are the difficult blocking points in the system, and not just to blame and yell at them or do other things, but to understand that it's a systemic problem that has to be part of the solution. But anyway, I don't want to take up more time.
Well, but let me respond. Michael Mann, the point to which that you are attributing to Michael Mann, I totally agree with. There's no question that there's clear evidence that the fossil fuel industry used a similar tactic to the tobacco industry in trying to create confusion about whether climate change was real in the first place, and if so, who was to blame. All of that's true. I don't think that's going to get you past St. Peter at the pearly gates. I still think that if
I'm a Unitarian too, so I'm not worried about it.
Yeah, so to deify the thing, that doesn't get me off of my ethical hook. I still have the choice to buy gasoline or not. I still have the choice to eat sushi or not, to eat beef or not. All of those are choices that are in my remit to make, and nobody's forcing me to eat sushi. I don't think we're utterly captives of some system we can't control. We also, Exxon's a bad guy, and we all make choices that, that are incompatible with the climate we would hope to see. But how does one convince the world to give up stuff the world covets? I don't know. I'm not claiming to be an exemplar. In fact, my ethical question is how do I explain to my great-grandchildren, whom I don't have any of, how I continue to live the life I'm living? I don't know. But I'm going to the UK tomorrow, not going on a boat.
Thank you.
Edmund Robinson, I kept looking, if this is supposed to be a sort of a comprehensive guide to the whole problem, what I missed was the thing that scares me, I think the most, is the permafrost melting and releasing methane. So an example of something that's, as the global warming, we get deeper into things that accelerate global warming. Are there things like that that you haven't mentioned? And because
sure, there are loads of things that scare the bejesus out of me. Again, the disappearance of mountain glaciers would ruin agriculture all over the world. These deadly heat waves, I'm deeply worried that if people start dying in their beds, and P.S. if 100 people die, 1,000 cows and sheep and goats died, it's a disaster. I worry about climate migration being driven by agriculture no longer functioning in places that it now functions. And those are the places where the world population is still growing. If you want to really, need to hide under your covers at night, the global, the Atlantic Meridional Overturning Circulation, the AMOC, is a big waterfall in the North Atlantic south of Iceland, a waterfall in the sea whereby surface water, for reasons that are too long to get into, plunges to the bottom of the ocean. And this is the main, there are a few other places in the earth where this happens, but this is the main one. And it's what drives the Gulf Stream that keeps Europe warm. And it's the process by which the waters of the oceans overturn, and top water goes to the bottom, and that drives bottom water back up somewhere else. The AMOC is slowing down and might stop altogether. That would just change, climate patterns all over the earth. We really are sailing off the edge of the map. Now, since everything I've said here is negative, this is a very backhanded, not negative statement, but I'm still more worried about nuclear war than I am about this. So, of things to worry about, I don't think that climate is going to be the end of humanity. I don't think it's going to be the end of civilization. I don't think it's going to be the end of the United States. But I think we're baking really big problems into the future that our successors on this planet are going to be very unhappy with us about. And I don't know how to stop it.
thank you.
Wait, to follow up on your comment about you're more worried about nuclear war. Earlier in the week, we looked at some survey data about what people around the world and the US are worried about. And actually, they're more worried about global warming. They see that as a bigger risk than nuclear war. I actually find that hopeful. And I don't see any other questions, so I'm going to ask the last one. And please, please, please give us an answer. It's almost bedtime. What do you find hopeful?
Humanity is ingenious. We're talking about existential problems. So despite the fact that the problems will be really big, we're going to have to find ways to solve them. I don't again, I don't see us making the planet uninhabitable. People talk about that, and I don't see that. I think technology ultimately will bail us out. It will just bail us out way later than people currently have in mind. And so we will endure a lot more climate damage in the interim that people have in mind. But this just isn't the end of society or humanity or the United States or civilization. I don't see it that way, but I do think we're doing a lot more damage than we realize, and that we will do a lot more damage than we realize because we won't stop soon enough. But people will still be here 100 and 200 and 300 and 400 years from now. I don't see this in that way. I guess I'm also not a doomist. No matter how bad it gets, it could always get worse if we don't do the right thing. So there's always an opportunity to do the right thing, even if I'm concerned about the destination to which we're headed. So I wake up every morning happy to get to work on this.
Let's get to work.
Yep.
I'd like to thank everyone and thank Wade, please.
Thank you. My pleasure.